We're going to write the decimal value of the constant that will enable only the blue and green LEDs, assuming a 2's complement notation. So we want the decimal values. That means we are going to have 8 bits, 1, 2, 3, 4, and then 1, 2, 3, 4. So we can have 8 bits here. We remember that it's going to be to the power of 0, to the power of 1, to the power of 2, to the power of 3, to the power of 4, 2 to the power of 5, to the power of 6, and then 2 to the power of 7. So what this is saying is we want to write the decimal value constant. It's going to only enable the blue and the green LEDs, and assuming 2's complement notation. So the first thing that we're going to need to check is this last bit right here. Now, if this last bit is high, that means we have a negative number. We're going to have to invert the bits. So since we don't have that here, we are not going to worry about that. Only blue and green are lit, and this is for 2 and 1. So the rest of these are going to be zeros. So we can write these out as zeros. This is going to be 1, this is going to be 1, and this is going to be 0. Remember, 2's complement, what you would have to do, if this is as 1, you would invert the bits, and then you would need to add 1 to the back right here. But that'll be in another example in playlist below in the description. So for this one right here, we're not inverting anything. We're just going to simply add these two together. So 2 to the power of 2 times 1 and 2 to the power of 1 times 1 is just going to give us 4. And then we have a plus 2. We add them together. That's going to give us a 6. And that's how we would go about looking at this problem.